Hello, good morning students. Today we have to discuss the topic limit and continuity. Now the idea of limit. लिमिट की अगर हम बात करते हैं तो लिमिट किसी भी फंक्शन के लिए सपोज a function is there and it is a point x is equal to a. Now we have to take 2 points in the neighborhood of a. इस तरह से सपोज इट इज a प्लस एच और दूसरा पॉइंट हमने ले लिया a माइनस एच. नाउ लेट y इज इक्वल टू एफ एक्स इज अ गिवन फंक्शन एंड व्हेन द वैल्यू ऑफ x अप्रोचेस टू a फ्रॉम राइट साइड, that is the x tends to a plus or a plus h, then it is known as the right hand limit. Similarly, when x approaches to a from left side, यानी कि इस साइड से जब होता है लेफ्ट साइड से like this, तो that will be the left hand limit. राइट साइड से अप्रोच करेगा इस पॉइंट की तरफ, that will be the right hand limit, a minus h, and it is known as the left hand limit. So we use the symbol limit x tends to a or a minus h or a plus h. So this symbol is known as the tends to, x tends to a minus h. तो यहाँ पे लेफ्ट हैंड लिमिट राइट हैंड लिमिट का जो आइडिया है वो इस तरह से कैलकुलेशन होगा इसका. अब इसमें कुछ फार्मूले हमें पता होने चाहिए तभी हम लिमिट्स कैलकुलेट कर सकते हैं. टू फाइंड द लिमिट्स in different cases, to find the limits in different cases, यहाँ पे कुछ ऐसे फार्मूले हैं विच विल बी यूज डायरेक्टली. कुछ फार्मूलों को हम डायरेक्टली यूज कर लेते हैं लिमिट्स कैलकुलेट करने में. एंड वन ऑफ देम इज लिमिट x टेंड्स टू 0 sin x अपॉन x and its value will come out 1. Similarly, second is limit x tends to 0 tan x upon x and its value is also 1. Third one is limit x tends to 0 log 1 plus x upon x and it will also come out 1. So these are the formula which can be used directly to evaluate limits. और उसके बाद एक और फॉर्मूला देखते हैं. It is also important from point of view of competitions. If limit x tends to 0 1 plus x whole power 1 upon x, तो that will come out e. इस रिजल्ट का एक और भी है. लिमिट x tends to infinity 1 plus 1 upon x whole power x, the same value will come out e. And 5-1 is limit x tends to 0 a power x minus 1 upon x, that will be equal to the log a where a is greater than 0, a is positive. And one more result is there. Limit x tends to 0 1 plus ax whole power 1 upon x and that will be e power a. So these type of formula can be used directly for calculating the limits. Now some expansions are also there which are important whenever we will discuss the questions of limits. So that expansions are already studied. One of them is binomial expansion which we have already studied in class 11th. 1 plus x whole power n, that will be equal to 1 plus nx plus n minus 1 upon factorial 2 into x square. So before solving the questions of limit, a person must know these formulas. Number second, e power x it is equal to 1 plus x upon factorial 1, x square upon factorial 2, plus x cube upon factorial 3, and dot dot so on. Similarly, number third, that is log 1 plus x. Log 1 plus x base e, that will come out x minus x square upon 2 plus x cube upon 3 minus x power 4 upon 4 plus dot dot and so on. And a power x is also there. A power x is equal to 1 plus x log a base e upon factorial 1 plus x square log a base e whole square upon factorial 2 plus dot dot and so on. Two more formulas will be used often, and they are sin x. Sin x will be equal to x minus x cube upon factorial 3 plus x power 5 upon factorial 5 minus x power 7 upon factorial 7 plus dot dot. And similarly, the cos x will be equal to 1 minus x square upon factorial 2 plus x power 4 upon factorial 4 minus x power 6 upon factorial 6. So all these formulas a student must be acquainted whenever he is trying to solve the questions of limits. There are some theorems on limits. After that, we have to see how to solve the questions. So these theorems on limits are: if there are two functions and limit x tends to a fx and limit x tends to a gx exist, if these limits exist, तो यहाँ पे कुछ रिजल्ट्स हैं जो सेटिस्फाई होंगे. लिमिट x टेंस टू a fx plus minus gx, that will be equal to the limit x tends to a fx plus minus limit x tends to a gx. So that is the first. Second one is limit x tends to a fx into gx, that will be equal to the limit x tends to a fx multiplied by limit x tends to a gx. So it is the second theorem. And the third one is limit x tends to a fx upon gx, so that will be equal to limit x tends to a fx upon limit x tends to a gx. So these theorems will be useful for solving the questions of limits, so you must know it. Now there are some methods how to evaluate the limits, and the method 1, when limits tends to infinity, when limit tends to infinity. इसके लिए एक एग्जाम्पल देखते हैं यहाँ पे. सपोज वी हैव लिमिट n tends to infinity 4n cube plus 3n square plus 7n plus 1 upon 3n cube plus 5n square plus 3n plus 9. Now when the limit is tending to infinity and the terms are in quotient form p upon q form, तो यहाँ पे हम क्या करेंगे, जो न्यूमरेटर और डिनोमिनेटर में हाईएस्ट पावर होगा अननोन क्वांटिटी का, दैट इज द n, उससे हम डिवाइड कर देंगे. तो ये बोथ इन न्यूमरेटर एंड डिनोमिनेटर द हाईएस्ट पावर ऑफ n इज n पावर 3. तो वी हैव टू डिवाइड both numerator and denominator by n cube. So that will be equal to the limit n tends to infinity 4n cube upon n cube plus 3n square upon n cube plus 7n upon n cube plus 1 upon n cube. Similarly, it will become out 3n cube upon n cube, 5n square upon n cube plus 3n upon n cube plus 9 upon n cube. So on simplification, the result will come out limit n tends to infinity 4 plus 3 upon x plus 7 upon x square plus 1 upon x cube whole upon 3 plus 5 upon x plus 3 upon x square plus 9 upon x cube. And we know that when n will tend to infinity, so n tends to infinity, 1 upon infinity will come out 0. So all these values in denominators, they will be equal to the 0. ये सारी values 0 हो जाएगी and the result will 1 upon infinity is 0. So all these terms will be 0, only 4 and 3 will be left, and which will be the required answer of this limit. So it is the first method. Now the second method is to find the limit using rationalization. Rationalization is a process which we studied in previous classes and that will be applicable here. Suppose, for example, we have a question that limit x tends to 5, 1 minus root x minus 4 upon x minus 5. Now here we have to rationalize it. For the purpose, we have to multiply both numerator and denominator by 1 plus root x minus 4. So that will be 1 minus root x minus 4 upon x minus 5 into 1 plus root x minus 4 upon 1 plus root x minus 4, and the result will come out limit x tends to 5, 1 minus x minus 4, so that will be the plus 4 on changing the sign, and it will come out x minus 5 and 1 plus root x minus 4. Now it will become out 5 minus x, so that will be the limit x tends to 5 minus x upon x minus 5, 1 plus root x minus 4. Now here these quantities will be cancelled out by a difference of minus. So here it will be cancelled out and it is minus. Put the value of x, so that will come out minus 1 upon 2. So it is the second method of solving the limit. Now there is one third method is also there, which formulas we have studied, that will be also used here. The third one is to find the limit using substitution. Substitution method is also a method by which any problem of limit can be solved. Now for this, take an example that we have limit x tends to infinity sin x upon x. Let x is equal to 1 upon y. So when x will tends to infinity, then y tends to 0. So converting in terms of y, the limit will also change. It will be y tends to 0 and it will be sin 1 upon y upon 1 upon y, or we can write it in simplified way as limit y tends to 0 y into sin 1 upon y. Now we know that sin 1 upon y is a finite value. Sine function has a finite value lying between minus 1 and plus 1. So that will be, and y tends to 0, so that will be 0 into a finite quantity. And the result will come out 0. So the value of the limit will come out 0. Now in fourth form there is also a situation may occur when there are indeterminate forms. Indeterminate forms are the forms in the shape of 0 upon 0 or infinity upon infinity or 1 power infinity, 0 power infinity, infinity power 0. So all of these cases are known as the indeterminate forms, and in order to evaluate the limits in these cases we have to use L'Hospital's rule. L'Hospital rule को यूज करेंगे. L'Hospital rule क्या होता है आपका? In this case we differentiate numerator and denominator separately until the form is removed. जब तक ये form remove नहीं हो जाएगी हम numerator और denominator को differentiate करेंगे, उसका differentiation करेंगे. For example, let us see a example that you have to solve limit x tends to 0 1 minus cos x upon x square. Now it is the form of 0 upon 0 because when we substitute the values of x, the cos 0 is 1, 1 minus 1 is 0 and it is also 0. So it is taking the form of 0 upon 0. So we have to use L'Hospital's rule और इसको यूज करने के लिए हमें इसका डिफरेंशिएशन करना होगा. डिफरेंशिएशन कांस्टेंट का 0 होता है एंड cos x का डिफरेंशिएशन दैट विल बी द माइनस साइन x एंड सिमिलरली x स्क्वायर इज इक्वल टू 2x. अब यहाँ पे जब डिफरेंशिएशन कर लिया तो जो फॉर्म आ रही है दैट इज साइन x अपॉन 2x. तो दैट विल बी इक्वल टू लिमिट x टेंस टू 0 साइन x अपॉन 2x. अब यहाँ पे दो केसेस अराइज कर सकते हैं क्योंकि अगर हम फॉर्म देखें तो स्टिल इट इज 0 अपॉन 0. तो यहाँ पे हम इसको फिर से एक बार फर्दर डिफरेंशिएशन कर सकते हैं. L'Hospital रूल को कंटिन्यू रख सकते हैं. तो x टेंस टू 0 साइन x का डिफरेंशिएशन फिर आपका cos x हो जाएगा और 2x का 2 हो जाएगा और अब आपकी फॉर्म रिमूव हो जाएगी. नाउ पुट x टेंस टू 0 तो cos 0 इज 1 तो दैट विल बी द 1/2. और यहीं से एक सेकंड केस भी अराइज हो सकता था कि हम दोबारा से L'Hospital रूल ना यूज करते, कांस्टेंट टर्म को बाहर ले लेते, लिमिट x टेंस टू 0 साइन x अपॉन x एंड इट इज द वेल नोन फॉर्मूला, वेल नोन लिमिट जिसकी वैल्यू 1 होती है. अभी हमने स्टार्टिंग में बता दिया था आपको दैट इज हाफ इंटू 1. तो रिजल्ट विल आल्सो कम आउट हाफ. तो इन डिफरेंट क्वेश्चंस डिफरेंट सिचुएशंस में अकर तो वी हैव टू टैकल अकॉर्डिंग टू द कन्वीनियंस ऑफ द प्रॉब्लम.